All right, in this video, we'll talk about section 5.2 dealing with multiplication and division of integers. And in this video, we'll multiply using various models. We'll multiply integers using various models. Also identify and use properties and multiplications of integers to simplify expressions, and then divide integers using the definition, and also perform order of operations on integers and solve inequalities with integers. Okay. So let's talk about some of the integer multiplication models here. Multiplication of integers is approached through a variety of models: shift, number line, and pattern. Reasoning with these models is inductive and is used to motivate the operations. So we'll start off with the use of the shift model, as you can see here. Okay, so here we can use this to illustrate multiplication of integers. So here we can picture 3 times -2 by putting 3 groups of 2 red chips, as you can see. Each group has 2 red chips. There are 3 groups. So 3 times -2 would be -6. Now, if I want to find 3 times -2 to be equal to -6, we start off with a value of 0 that includes at least 6 red chips, and then remove the 6 red chips. So here, a 0 pair, a value of 0. So I'll do 6 yellow and 6 red chips. That represents a 0 pair. And let's remove 3 groups of 2 red chips. Okay, removing them, we're subtracting 3, that's -3. And each group has 2 negative chips. You're left with +6 chips. So -3 times a -2 would be +6. Also, we can use a number line model for addition. Not for addition, for multiplication. So here we can demonstrate multiplication by using a cat moving along a number line. And here are the rules. Always start at 0 and always face the positive direction, which is going to be going to the right. If the number is positive, you'll walk forward, or if the number is negative, you'll walk backward. So in this case, here we got 2 times -3 represented in this particular model. 2 times -3. So notice in this case here, we started at 0. Here, the 3 is negative, so we walk back 3 places, and then we walk back another 3 places twice. So here, 2 times -3, that's -6. Right, and also in this case here, if we were to do -3 times -2, then of course we walk back 2 places. Walk back 3 places twice to end up with -6. So now the opposite of -6 would be 6. That would be a representation of -2 times -3. All right, now for the pattern model. Let's first find 3 times -2 using repeated addition. So here, -2 will be added 3 times. So -2 times -2 times -2 would be -6. And now we use the commutative property to find -2 times 3. Well, -2 times 3 is the same as 3 times -2, which is, of course, -6. And now to find -3 times -2, we can find a pattern. Like starting with 3 times -2, that would be -6. Now here we're decreasing the first factor by 1, as you can see. And then you'll see the pattern here. Down to 2 times -2, that'd be -4. Then 1 times -2 would be -2. 0 times -2 would be 0. And then For -1 times -2, it will have to be 2, okay? Because we're moving along 2 places each time from left to right. So pretty much you can see what the pattern is. All right, now let's define integer multiplication. Here we're going to let A and B be integers. If A is greater than or equal to 0 and B is greater than or equal to 0, then A and B are going to be whole numbers with a product of A times B. So if A and B are positives, then that means you just multiply them as you would whole numbers. But let's say A is less than 0, which is negative, and B is less than 0, which is also negative. Then if you multiply A and B, you're going to multiply the absolute value of A times the absolute value of B. And keep in mind, absolute value is always going to be positive. So this is another way of saying if you multiply 2 integers with the same sign, both negative, your product will be negative. And part C of if one or more, if one of A or B is less than 0, if either A is negative or if B is negative, while the other is greater than 0, then A times B will be the opposite of the absolute value of A times the absolute value of B. This is another way of saying if you multiply 2 integers with different signs, where one is negative and the other one is positive, your answer will be negative. Okay. So here's a homework example that we can look at. Evaluate each of the following products and then, if possible, write 2 division statements that are equivalent to the given multiplication statements. If 2 division statements are not possible, explain why. So here we got, in this case, -6 times 5, and then -6 times -2, and -7 times 0. So in this case, let's start with -6 times 5. Here we're multiplying 2 integers with different signs. So that means the answer would be negative, and then 6 times 5 would be 30. So my answer there will be -30 for -6 times 5. Now, let's come up with 2 division statements for this. One division statement is this: if I take -30, divide that by, let's say, -6, that will be 5. And the other one, if I do -30 divided by 5, I would get -6. So those are 2 possible division statements. And then -6 times -2, I'm multiplying 2 integers with the same sign. So that means my answer is going to be positive. So -6 times -2 would be 12. Now the 2 possible division statements would be something like this: 12 divided by, let's say, -6. That'd be -2. Oops. -2. And then the other one, 12 divided by the other factor, -2, would be -6. So those are 2 possible division statements. And now for -7 times 0. Well, 0 times any integer is automatically going to be 0. And let's say I want to write 2 division statements for that. If I do 0 divided by 7, that would be, -7. 0 divided by -7, that would be 0. And that would be the only division statement, because if I wrote this 0 divided by the other 0 to be -7, that would be a false statement. And that's because division by 0 is undefined. And we pretty much talked about this when we were doing division of whole numbers back in section 3.5. So the only division statement will have to be 0 divided by -7, which is 0. All right, here's another homework example problem. The market price of a company stock dropped $4 per hour for 2 hours. Write this information using integers and find the total points the stock fell. Okay. So in this case right here, it dropped $4 per hour, so that's -4. For 2 hours, that'll be times 2. So something like -4 times 2, that would give us, in this case, -8. So to answer the question, the company stock dropped $8 over the 2-hour period. Okay. Here's another homework example. If it was predicted that the farmland acreage lost to family dwellings over the next 9 years would be 11,000 acres per year, how much acreage would be lost to homes during this time period? Okay, so if we lost 11,000 acres per year, that's -11,000. For 9 years, that would be times 9. So if I multiply -11,000 times 9, that would be -99,000. So to answer the question, the acreage that would be lost during that time period to homes would be 99,000. Right, on the next page. Now, these are the properties of integer multiplication. These are just similar to the properties of whole number multiplication. Okay. The closure property states that if I multiply A times B, where A and B are in the set of integers, I would get a unique integer. And then the commutative property states if I multiply A and B together, I should get the same result as if I multiply B times A. So again, the order does not change the answer. -3 times 2 would be the same as saying 2 times -3. I would still get -6. Then the associative property of multiplication of integers, I can multiply A and B together, then multiply it by C. They'll be the same as if I multiply B times C together and multiplied it by A. The answer will be the same. Then the identity property of multiplication, where in this case, 1 would be the unique integer, where 1 times any integer would be that integer, and also that integer times 1 would be that integer as well. And then we have the distributive property of multiplication over addition for integers. That means if I had A times the quantity B plus C, I can distribute the A over the B and the C through multiplication. I get A times B plus A times C. And the same here. B plus C, that quantity multiplied by A, it'll be distributed over the B and the C through multiplication of B times A plus C times A. And keep in mind that A, B, and C are in the set of integers. And also the zero multiplication property of integers, where 0 is a unique integer, such that if I multiply 0 times any integer, I would get 0, or any integer multiplied by 0 would be 0. Okay, and here are a few theorems related to this. -1 times A, that would be the opposite of A, or negative A. And then -A times B, which is the same as B times -A, that would be the negative of the product of A and B. And then -A times -B, that would be AB. That means if I multiply 2 integers with the same sign, it's going to be positive, AB. And then we have the distributive property of multiplication over subtraction, for integers, same as for the ones for the distributive property for multiplication over addition. A times the quantity B minus C, that'd just be A times B minus A times C. And the same holds true going this way, B minus C, that quantity multiplied by A. That'll be B times A minus C times A. Okay, so now let's look at this example where we're going to identify the properties of integers being illustrated in each of the following. All right, so let's take a look at this one. -2 times the quantity 5 plus 4, that's equal to the quantity of 5 plus 4 multiplied by -2. Notice that the order of these factors have changed. The order of those factors have changed. So this represents the commutative property of multiplication. Commutative property of multiplication. All right, part D, -3 times -2 is going to give us integer I, or is an element of I. Well, -3 times -2 would give us a unique integer, so that means this will have to be the closure property of multiplication. Okay. Now part C, 4 times 5 times -2 is equal to 4 times 5 in parentheses times the -2. Notice that -5 plus -5, well, 5 times -2 is in the bracket, and then we got 4 plus 5 in parentheses here. The grouping has changed, but we're still going to get the same answer. So this represents the associative property of multiplication. The associative property of multiplication. And then part D, we got -6 times the quantity 8 plus -1. That's equal to -6 times 8 plus -6 times -1. Notice that the -6 has been distributed over the 8 and the -1 through multiplication. So this is the distributive property of multiplication over addition. Okay. So that's how we identify the properties being illustrated in those examples. All right, here's another example. Let's say we want to simplify each of the following so that there are no parentheses in the final answer. Like in this one, -3 times the quantity x minus 2. So when I distribute, this will be -3 times x. And I'll pretty much write this out, -3 times x, and then minus -3 times the 2. Well, -3 times x, that's -3x. Now, the minus of -3 will make that a plus. So that'd be 3 times 2, which would be plus 6. So I'm going to end up with -3 plus -3x plus 6 as the final answer. Okay. Now in the homework example, we're going to multiply each of the following and combine terms wherever possible. So in part A, I got -3 on the outside times P minus Q. So a negative, but what it's going to do here is change the sign of every term inside the parentheses to the opposite. So if I do -3 times P, that's -3P. And the negative 3 times minus q would be a plus 3q. So I end up with negative 3 plus 3q. Part B, p times the quantity p minus q. Well, using the distributive property, p times p would be p to the second or p squared, and then minus p times q, just say pq. So I end up with p squared minus pq. Now part C has the negative in front of the p times the quantity p minus p minus q. Okay, if I do negative p times positive p, it will be negative p squared, because p times p is p squared. And then the minus times the minus p times the minus q, well, minus times this negative will be a plus pq. So I get negative p squared plus pq. And then part D, negative 3 times p plus q minus r. Well, using a distributive property, negative 3 times p would be a negative 3p. The negative will make the plus a minus, so 3 times q would be minus 3q. And then again, this minus sign will make that negative a plus. So I have minus, so I know 3 times r would be 3r. So I'll end up with negative 3p minus 3q plus 3r. Okay. Now let's consider something like this. Let's say we had x plus 4 times x minus 4. Now, if I use the distributive property, this x plus 4 would be distributed over the x and the minus 4. As you see here, I have x plus 4, that quantity times x, minus the x plus 4 times that quantity times 4. And then we use the distributive property here. Do x times x as x squared, and then x times the 4 would be plus 4x. And then bring down the minus sign, and just focus on distributing the 4 over the x plus 4. 4 times x will be 4x in parentheses, and then 4 times 4 will be 16, also in parentheses. If we change subtraction to adding the opposite, it would be this x squared plus 4x plus negative of the quantity 4x plus 16. And distribute the negative over the 4x and the 16, you'll get negative 4x plus the 16. We'll add that to the x squared plus 4. Now notice that x squared 4x and negative 4x adds to 0. You'll be left with x squared minus 16. Now this result that we came up with is what we call the differences or the difference of squares formula, which is this right here. For all your integers a and b, a plus b times a minus b. If you have the sum and the difference of the exact same two terms, what you do here is square the first term and then minus the square of the second term. We're going to apply that to these examples here. So if I want to use the difference of squares formula to simplify the following. In part A, I got 4 plus b times 4 minus b. I have the sum and the difference of the exact same terms. So what I'm going to do here is square the first term, which is the 4. That's going to be squared. Then it's going to be minus the square of the second term. B. If I simplify this, 4 squared is 4 times 4, that's 16, minus b squared, well, b raised to the second would just be b squared. So I'm going to end up with 16 minus b squared. Part B, again, -4 plus B times -4 minus B. Here I got the sum and the difference of the same two terms here. I'm going to apply that difference of squares formula by squaring the first term. That first term is -4, and that's squared. And that'll be minus the square of the second, the B, and that'll be squared. -4 u squared will be -4 times -4, that's 16, minus the B will just be squared. So it'd be 16 minus B squared. All right, let's talk about factoring. When the distributive property of multiplication over subtraction is written in the reverse order as this, AB minus AC equaling to A times the quantity B minus C, and of course BA minus CA is equal to B minus C, that difference multiplied by A. The expressions on the right of the equation are in what we call factored form. And we can also say that the common factor, which is in this case A, has been factored out. So both the difference of squares formula and the distributive properties of multiplication over addition and subtraction can be used for factoring. All right, like in this example, let's say we get x squared minus 9 in part A. Now notice in this problem here, we have squares. We have an x squared, and 9 is what we call a perfect square. We have a difference of squares. We can factor this out into two binomials like this. The x squared breaks up as x and x. And if it's a difference of squares, one has to be a positive, well, one has to be plus, the other one has to be minus. That's always the case with differences of squares when you factor it. And then we have to find out what number times itself will give you 9. Must be 3, because 3 times 3 gives us 9. So factor completely, x squared minus 9 would be x plus 3 times x minus 3. All right, part B, we got x plus y quantity squared minus z squared. Notice this is squared and that's squared, a difference of 2 squares. We can factor this out into two binomials here. This x plus y quantity squared breaks up as x plus y times x plus y. Now, since it's a difference of squares, one must be plus, the other one has to be minus. Z squared breaks up as z times z. So x plus y quantity squared minus z squared factors as x plus y plus z times x plus y minus z. Now in part C, we got negative 3x plus 5xy. In this case here, we're not going to be able to use the difference of squares formula, but we can find a common factor that's in negative 3x and 5xy. And if you look at it very carefully, you see that x is in both of these. So that would be the common factor. So we pull the x on the outside. To get what's left, we're going to take the x, divide that by each and every term in that common factor in this expression. So if I do negative 3x divided by the x, that'd be negative 3, and then plus 5xy divided by x. That'd just be 5y. And if you want to, you can check by distributing the x over the negative 3 and the 5y. You should get this back. So that's how we do factoring here. Okay. Now let's look at some homework problems related to that. All right, so here we're going to factor the following expressions completely. Like in part A, we got 12w plus 19w. Well, notice here we have a common factor in 12W and 19W. That would be the W. So the W will be on the outside of the parentheses. That's the common factor. And then we divide 12W by W to get 12 plus 19W divided by W. That would be 19. And don't worry about doing the 12 plus 9, which we know is going to be 31. They just want you to factor this completely. All right, part B, FG plus F. Well, looking at that expression, the common factor that's in both FG and F will be F. So the common factor will be on the outside of the parentheses, the F. So if I do FG divided by F, I'll be left with G. And then plus F divided by itself would be 1. So it'll be F times the quantity G plus 1 when we factor this out completely. Okay. Part C, F squared plus FG. With that, the common factor is F. However, we want to pick the variable with the smallest exponent. So it'd be F to the first power, or just F. Okay, that's always going to be the case. You want to select the one with the common variable with the smallest exponent. So if I factor out the F, F squared divided by F would only leave me with just an F. And then plus FG divided by F. That would be G. So it's F times the quantity F plus G. And you can check this by doing F times F, which is X squared, then plus F times G, which will be FG. Part D, 2FG plus 3F minus FH. Well, we need the common factor that's in all three of these terms. And by looking at this, I see an F and an F and an F. So I can factor out the F. Okay, so when I factor out the F, 2FG divided by F, you'll be left with 2G. Plus 3F divided by F, you'll be left with 3. And then minus FH divided by F, you'll be left with H. So it'll be F times the quantity 2G plus 3 minus H. Part E would be X, Y, Z plus XY minus X. By looking at this, the common factor in all three of these is X. So I'm going to take out the X, divide each of these terms here by X. XYZ divided by X will leave me with YZ, plus XY divided by X will leave me with Y, minus X divided by itself would be 1. So I have X times the quantity YZ plus Y minus 1. Now part F is the difference of squares, 25 minus X squared. Notice that 25 is a perfect square, X squared is a perfect square. That's the difference of difference of squares, I should say. I can factor this into 2 binomials here, like this. I have to think of what number times itself gives me 25. That's going to be 5. And it's a difference of squares. One must be plus, the other one has to be minus. And X squared breaks up as X times X. So 5 plus X times 5 minus X would be what 25 minus X squared is. And finally, part G, 25 F squared minus 16 G squared. Notice that's a difference of squares. So I can factor this into 2 binomials here. Now here I have to think of what number times itself would give me 25. That would have to be 5. And of course, f squared, I write that as f. So I have 5f times 5f. It's a difference of squares, so that means one must be plus, the other one has to be minus, and then I think of what number times itself will give me 16. It will have to be 4. And of course, g squared will have to break up as g times g. So I have a 4g here and a 4g here. So factor completely, it'll be 5f plus 4g times 5f minus 4g. Okay. All right, now let's talk about division of integers. And let's look at some models here for division of integers. The set of integers is not closed under division. And the models shown use integers that do have integer quotients. So if I use a chip model, here I can partition or divide -15, which is represented by this, into 3 groups. So I have 3 groups of -5 dots. But I'm going to take out or subtract 2 groups of -5, which means I will have, in this case, -5, which represents the fact that -15 divided by 3 equals -5. All right, now for the pattern model for division. Division can be motivated by using whole number patterns. The table below shows division by 2 and -2. Completing the pattern for even whole numbers to 0 and opposites of the even whole numbers, we notice the results decrease by 1 for division by 2 and increase by 1 for division by -2. This pattern suggests that a positive integer divided by a positive integer is positive, that a negative integer divided by a positive integer is negative, that a positive integer divided by a negative integer is negative, and a negative integer divided by a negative integer is positive. Okay, so here's what that table looks like, and that's what the pattern is in this case. Now, it does follow the fact that if you divide integers with like signs, you're going to get an answer as a positive. Or if you divide integers with unlike signs, divide 2 integers with unlike signs, it's going to be negative. Divide 2 integers with like signs, it's going to be positive. So here's the definition of integer division. For all integers a and b, a divided by b is a unique integer c if it exists such that a is going to be equal to b times c. So let's use that definition to divide these types of integers. Like in part A, 12 divided by -4. So that means that there is some integer c where, in this case, -4 times c would give me a positive 12. And we have to think of 4 times what integer would give me 12. Has to be -3. So 12 divided by -4 would be -3. And what about 12 divided by -12 divided by 4? That means that there's some integer c such that 4 times c gives me -12. In this case, again, -3. And then 12 divided by -4, there's got to be some integer c where -4 times c gives me -12. Well, in this case here, it has to be a 3 because 4 times 3 will only give me -12. Now let's look at negative 12 divided by 5. That means I need to find some integer c where 5 times c is equal to negative 12. Now, integers are whole numbers. They're not going to be fractions or decimals. Integers, again, are whole numbers. There are no integers that will satisfy this equation. So here, over the set of integers, this is undefined. Negative 12 divided by 5 over the set of integers is undefined. Now, parts E and F are just variables here. In part E, we got AB divided by B, where B is not equal to 0. Now, if you want to, you can write it like this, AB over B, and simplify that. As long as B is not equal to 0, I can divide out the B. You'll be left with just A. So AB divided by B will be A. And on a similar note, AB divided by A, where A is not equal to 0, can be written like this. And as long as A is not equal to 0, I can divide out the A, and you'll be left with just B. So AB divided by B, AB divided by A would be B. Okay. All right, next we'll look at another homework example. Here's the definition of division to find each quotient if possible. If a quotient is not defined, explain why. Like negative 32 divided by negative 8. Negative 32 divided by negative 8. We're dividing two integers with the same sign. So we know the answer has to be positive. So if we do negative 32 divided by negative 8, we'll get 4. And in part B, negative 143 divided by 13. In this case here, we're dividing two integers with different signs. So the answer, of course, will be negative. So let's see, 143 divided by 13 would be 11. So negative 143 divided by 13 would be negative 11. Now, what about negative 5 divided by 0? Okay. This one is, of course, undefined. Okay. Because division by 0 is always going to be undefined. Any number divided by 0 will always be undefined, because you're not going to come up with some number where 0 multiplied by that number would give you negative 5. Okay. All right, here's another homework example. Uncle Bob has a debt of $2,520. His 7 siblings offered to pay off all the debt. Write the information using integers and compute how much each sibling needs to pay in order to pay off the debt. So he has a debt of $2,520. I'll represent that as negative 2520. 7 siblings agreed to pay off the debt. So we divide by 7. So I'll use this calculator here. Put this out. Negative 2520. Sorry about that. Gosh. Negative 2520. Let me use another. I'll do this off the camera. Negative 2,520 divided by 7 would be negative 360. So that's how we can represent that answer as negative 360. Okay. So Now, in the homework, when you enter the amount that each sibling needs to pay off the debt, you'll drop off the negative, just say 360 as the answer. But this part right here is the division sentence for that situation. All right, on the next page is just ordering integers. And this is just a definition of less than for integers here. For any integers A and B, A is less than B, written as this with the less than symbol. If and only if there exists a positive integer k such that A plus some positive integer k equals B. Okay. And here's the theorem for this. A is less than B, or equivalently, B is greater than A, if and only if B minus A is equal to a positive integer. That is, B is greater than A, B minus A is greater than 0. And here's another theorem with some properties of inequalities of integers. If X is less than Y, and N is any integer, I can add N to both sides of the inequality and it will be true. If X is less than Y, then what will happen is this: I take the opposite of X and the opposite of Y. But when I do that, this inequality symbol changes from less than to greater than. Illustration of that would be something like this: 6 is less than 8. If I take the opposite of 6, it'll be negative 6. If I take the opposite of 8, it'll be negative 8. But I need the truth of this one, what negative 6 is. Negative 6 is closer to 0 than negative 8. So negative 6 is greater than negative 8. Now, if X is less than Y and N is positive, I can multiply that positive integer N on both sides. And it will be this: N times X is equal to N times Y. So 6 is less than 8 would be a true statement. But let's say I multiply the left side and the right side by 2. 2 times 6 is 12. 8 times 2 is 16. 12 is still less than 16. So I can multiply both sides of an inequality by a positive number, and the truth of the inequality would still be the same. Now, this fourth one, X is less than Y and N is less than 0. N is negative. If I multiply this on both sides by some negative number N, notice that the inequality symbol reverses. So with 6 less than 8, but let's say I multiply both sides by negative 2. Negative 2 times 6 is negative 12. Negative 2 times 8 is negative 16. But notice negative 12 is closer to 0 than negative 16 is. So negative 12 is greater than negative 16. So you see the inequality symbol reverses when you multiply both sides of an inequality by a negative number. So we're going to be using these to do these type of problems here. Starting with X plus 3 is less than negative 2. Well, I got a plus 3. What's the opposite of positive 3? Negative 3. So I'm going to add negative 3 on both sides of this inequality. Well, 3 and a negative 3 gives me 0. So this will be X is less than negative 2 plus negative 3, negative 5. So here this will be X is less than negative 5. Now, for part B, we got negative X minus 3 is less than 5. If I write that as negative X plus the opposite of 3, which is negative 3, is less than 5. Well, what's the opposite of negative 3? It'd be plus 3. So I'm going to add positive 3 on both sides of this inequality. That would mean I have negative X, that'd be less than 5 plus 3, which will be 8. Now, I got the negative sign in front of that X. I want to solve for positive X. Well, if I take the opposite of negative x, that would be x. But if I take the opposite of 8, it would be negative 8. And this inequality symbol changes to greater than. Or you could think of this as multiplying both sides by -1. You'll see your inequality symbol will have to change from less than to greater than. So I have x is greater than 8, -8. Okay. Let's look at these homework examples here. Like in this case here, -3, and we're going to cube it. -3, and we're going to cube it. Think of this as -3 times -3 times -3. Now, if I do -3 times -3, that would be +9. And then +9 times -3 would be -27. Okay. Part B, -2, and that's raised to the 4th power. Think of that as -2 times -2 times -2 times -2. Well, 2 times -2 will be 4. 4 times the -2 will be 8, -8. -8 times -2 will be 16. So with parts A and B, I'm raising a negative number to an odd power. That will always give me negative. Whereas in part B, I'm raising a negative to an even power. That's going to end up being positive. All right, now part C, we got -10 raised to the 4th divided by -10 raised to the 2nd. We're going to use one of those properties of exponents where we're dividing powers of the same base. So I'm going to bring over the base, which is -10, subtract the exponents. 4 minus 2 would be 2. And then I can simplify that. -10 squared would be -10 times -10, which would be 100. And that's the final answer. All right, part D, -3 raised to the 5th divided by -3. And that -3 would be like -3 raised to the 1st power. Again, I'm dividing powers of the same base. So I bring over that base, which is -3, and subtract 5 minus 1. That would be 4. So that'd be -3 to the 4th power, which is written out as -3 times -3 times -3 times -3. Well, 3 times 3 is 9 times -3 will be -27. -27 times -3 would be 81. All right, part E, -1 raised to the 54th power. And you don't have to write -1 54 times. Think of this, that negative is to an even power. And when a negative is raised to an even power, that's going to be positive. So -1 to the 54th power is just simply going to be 1. And for part F, here we got -1 raised to the 155th power. So that -1 is to an odd power. That's going to be -1. Because 1 to any power would be 1. But the -1 is to an odd power, so it has to be -1. All right, now part G, we got this. -2 times -2 plus 5 times 3 minus 1. I'm going to do this down here. So this is where some order of operations is going to come in. So here we got to do the 5 times 3 first, which will be 15. So I have -2 times -2 plus 15 minus 1. And then we do the addition and subtraction from left to right. So -2 plus 15, that's 13. 13 minus 1, not plus 1, minus 1. 13 minus 1 ends up being 12. Now part H. This would be 11 minus 2 times 8 minus 5 times negative 2 plus 3. And in this case here, we have to do some order of operations here. Let's start off with that 2 times 8. Bring this 11 down, do 2 times 8, that'll be minus 16. And then do minus 5 times 2. Minus 5 times negative 2. That will be plus 10, and then plus 3. Now we simplify this. 11 minus 16 is like 11 plus negative 16, which is negative 5. And then plus 10 plus 3. Negative 5 plus 10 would just be 5. And then finally 5 plus 3 would be 8. All right, now let's take a look at part I. Negative 2 raised to the 62nd power minus 2 to the 62nd power. Let's see if I can simplify this a bit. That negative to an even power would be positive. So this would just be 2 to the 62nd minus another 2 to the 62nd. That ends up being 0. And then finally, J, negative 2 to the 10th plus 2 to the 10th. That's simple. Negative 2 to the 10th and its opposite added together gives us 0 as well. Okay. So there you have it. All right, and the last set of problems here in this homework example, evaluate each of the following expressions if possible. All right, so let's start off with that negative 15 divided by negative 3, that would be multiplied by negative 6. Well, negative divided by negative is a positive inside this parentheses here. So negative 15 divided by negative 3 would be 5. And then 5 times negative 6. We're multiplying two integers with different signs, so it'll be negative 30. And then part B, negative 24 times 5 divided by 6. Start with the parentheses. We're multiplying two integers with different signs, so it's negative. 24 times 5 will be 120. And then negative 120 divided by 6 will be negative 20. Dividing two integers with different signs, so the answer has to be negative. All right, on this one, negative 16 divided by, and in parentheses, negative 8 plus 8. In this case here, if I add negative 8 plus 8, that would be 0. So I'll bring that negative 16 over. That'd be divided by negative 8 plus 8, that's 0. We got a problem here. We cannot divide negative 16 by 0. We can't divide by 0. So this is undefined. Undefined. Part D, negative 5 plus 5 divided by negative 2 plus 2. Work inside the parentheses, negative 5 plus 5. That's, of course, 0. That's going to be divided by negative 2 plus 2. That's 0. Here again, we got 0 divided by 0. That 2 is also undefined as well. And you might want to refer back to the video for section 3.5 dealing with division of whole numbers, where this right here, 0 divided by itself, is undefined. And now part E, absolute value of negative 36 divided by 4 times the quantity 8 minus 17. Well, let's find the absolute value of negative 36. That's 36. Divided by, let's work inside inside the parentheses here. Bring number 4, and you're going to do 8 minus 17. That's -9. Now, 36 divided by 4 times a -9 would be -36. Again, we're multiplying two integers with different signs, so the answer would be negative. And here we're dividing two integers with different signs. 36 divided by 36 divided by -36 is -1. So the final answer there would be -1. Okay, so that does conclude this video on section 5.2 dealing with multiplication and division of integers. I ask that you do email me if you have any questions about what's presented in this video, or if you have any questions about the homework that is in my math lab.